Welcome to qnawire.
So in this problem, we have to show that the ground state wave function of a hydrogen atom is normalized. And to do that, what we have to do is we have to integrate the probability distribution uh, over all space and show that this value is equal to 1. If we have done that, if we have done this, then we can confidently say that the wave function is normalized. So to do this, let's move on to the next page. So we are doing this integration over all space. We use the equation for the probability distribution uh, given to us, which is this e to the power 2r or r naught, and we do this over all space. So dv here represent the differential volume. So since the wave function of the hydrogen atom is just depends on the uh, radial distance, radial component, therefore the angular parts integrate to 4 pi r square. So we have, so the angular part integrates to 4 pi r square, and the radial part is just dr. And so since we are integrating it over all space, we go from r is equal to 0 to r is equal to infinity. So pi cancels, and we have the equation 4 over r naught cube integration from r is equal to 0 to infinity e to the power minus 2r over r naught r square dr. Now this might look a difficult problem, but can be made easier if we just substitute uh, x for 2r over r naught. So this gives us value for r as 1/2 x times r naught. So which basically means that dr is just 1/2 r naught times dx. Now for r is equal to 0, we get, so let me just write the equation for r real quick. R is 1/2 r naught times x. So when r is 0, x is 0, and when r is infinity, x is infinity. So this basically means that the equation from last page, uh, let's write that all space psi 110 square dv basically becomes that x goes from 0 to infinity. We have 4 over r naught cube, which was outside. It doesn't matter if we took it inside. The exponential becomes e to the power minus x, and then we have r square in front, so we just have to do this r naught x whole square, and for the value of dr we just substitute 1/2, okay, sorry, r naught dx. Now so we basically takes the all of the constant outside, so we have 4 over r naught cube, 1 over 2 r naught whole square, and 1 over 2 r naught. And inside we have x equals to 0 to infinity e to the power minus x times x square times dx. Now this 4 cancels with 2 square, and this r naught cube. Let me just write everything. Let me just elaborate everything. So we have r naught square from this square over r naught cube. Okay, let me just move on to the next page. So we basically have 1 over r naught cube. There is r naught square from 1/2 r naught whole square, and then there is 1/2 r naught from the differential element, and inside we have e to the power minus x square dx. Now we use the formula from appendix which is basically for any given integral of the form x to the power n e to the power minus ax dx, which goes from x is equal to 0 to infinity. This integral evaluates to n factorial a to the power n plus 1. So we just substitute this back over here. So r naught cube cancel with r naught square times r naught. So we just basically have 1/2. And here the value of n in the integral is 2. So we get 2 factorial, and the value of a is 1 because the factor multiplying to x in e to the power x is 1. So we have 1 is to the power 2 plus 1. So we basically have 1 over 2 times 2 factorial, which basically gives us 1. So the wave function is properly normalized. Thank you.